show that x equals 2i is a zero of this polynomial, and use that result to find all zeros of the polynomial. We're going to start using synthetic division. Since we're testing x equals 2i, we put 2i to the left of our synthetic division bar, and then we write in the coefficients of our polynomial. 1x to the fourth minus 2x cubed plus 7x squared minus 8x plus 12. And then we have our synthetic division bar underneath. So first we bring down the leading coefficient and then multiply. 2i times 1 is 2i. We then add these together. These are not like terms because one's real, one's imaginary. So this leaves us negative 2 plus 2i. We then multiply 2i times negative 2 plus 2i. To make sure we don't make a mistake, let's write this out over to the side. 2i times negative 2 plus 2i. If we distribute this through, this gives us negative 4i plus 4i squared. But I squared is negative 1, so this term becomes negative 4. Rewriting this, we have negative 4 minus 4i. So that will fill in the next spot on our table. Negative 4 minus 4i. And then we add these together. Combining like terms, we've got positive 3 minus 4i. And then we multiply. 2i times 3 minus 4i. We'll write that over to the side to make sure we don't make any mistakes. And we distribute this through, leaving us 6i minus 8i squared. But I squared is negative 1, so this whole thing we can replace with positive 8. Rewriting this, we have a positive 8 plus 6i. And that will copy over to the next empty spot on our table. And then we add these together. Combining like terms, the negative 8 and the positive 8 cancel, leaving us just positive 6i. And then we do one more multiplication. 2i times 6i. Multiplying these, we have 12i squared. But since I squared is negative 1, we can rewrite this as negative 12. We finally add these together and get 0 for our remainder. That confirms that x equals 2i is in fact a zero of this polynomial. Since all the coefficients are real, if x equals 2i is a factor, is a root, then x equals negative 2i. Its conjugate must also be a root. So we'll do synthetic division with the next zero, the x equals negative 2i. And we copy down our synthetic division bars. And we proceed. We copy down the leading coefficient and then multiply. Negative 2i times 1 is negative 2i. We then add these together. The positive 2i and the negative 2i cancel, leaving us just negative 2. And then we multiply. Negative 2i times negative 2 is positive 4i. We add these together. The imaginary parts cancel, leaving us with positive 3. And then we multiply. Negative 2i times positive 3 is negative 6i. Adding these together, everything cancels and we get a remainder of 0. Now if we look at the quotient that's left over after this, we had an x to the fourth, and we divided out successfully 2 times. That knocks the degree down on this twice to an x squared. So we have 1x squared minus 2x plus 3. Since we're asked to find all the zeros, let's set this equal to 0 and solve. In theory, we can solve this either by factoring or using the quadratic formula. I don't see a way to factor this offhand, so I'll use the quadratic formula. This gives us x equals negative b plus or minus the square root of b squared minus 4 times a times c. And this is all divided by 2 times a. We can simplify this to get x equals 2 plus or minus the square root of 4 subtract 12 over 2. We simplify this further to give us 2 plus or minus the square root of negative 8 over 2. And this radical we can simplify It's got a negative, so I know an I will come out of the radical. 8 is 4 times 2, so a 2 will come out and a 2 will stay inside the radical. And then finally, we can reduce this to 1 plus or minus I radical 2. Now they asked us to find all the zeros. This was a degree 4 polynomial, so we should have 4 answers. We have x equals 2i, x equals negative 2i, x equals 1 plus I radical 2, and x equals 1 minus I radical 2. We found 4 zeros to a degree 4 polynomial, so we know we have found all the zeros.